been a while since I've reviewed the neuroscience literature pertaining to both anxiety and exploration. And so maybe we could start by you laying out what you've discovered and how you're thinking about what you think anxiety signifies, how it's related to exploratory behavior, which I think you described as something approximating courageous approach, although you were talking about mice in that particular paper, and what you're thinking about with regards to the neural basis of these different behavioral and emotional responses.
Sure, I'd be happy to. And I should mention that these days my laboratory mainly focuses on humans. We still do some mouse work, but we, in partnership with people in psychiatry, we're doing essentially equivalent experiments in humans. So I'd be happy to elaborate there. Many people perhaps, but not everyone, have heard of the autonomic nervous system, which simply means automatic. It's a bit of a misnomer because without going too much into the history of that, if you look back to the origins of medicine in the time of Galen and so forth, when they were first, dissecting cadavers and whatnot, there was this idea of a nervous system, or a portion of the nervous system eventually came to be, that could control so-called vegetative functions, meaning the rate of digestion and the really what neuroscientists typically think of as boring stuff. But it's anything but boring. It's the stuff that keeps you from urinating while you're asleep, unless you're a very young child, right? And it's the stuff that keeps your digestion going as you command your attention to other things. The autonomic nervous...
Right. It's all the things that are too complex for us to think through.
That's right. And they are, as you point out, immensely complex. And, nowadays with all this interest in the gut microbiome and things of that sort, these are tremendously complicated operations that are happening generally below our conscious awareness, and that are indeed vegetative. They can be controlled by emotion. We were all familiar with the idea that when we are emotionally distraught, that our digestion can be different, or et cetera. But typically, we can't control, for instance, in a conscious way, the rate of our digestion or the speed of our heartbeat in any kind of direct way. We can have a particular pattern of thought to control those. But in general, those functions were thought to be vegetative and outside of our conscious control. And the name autonomic nervous system sort of swallowed and overtook the vegetative part. So it includes that, but also three main aspects of body to brain signaling. And those three aspects are heart rate, could be quickening or slowing of heart rate. We are, and we can be very aware of that, some of us more than others. Gut, and especially the chemical composition and the extent to which our gut is empty or full. So heart, stomach, and then rate of breathing and sort of depth of breathing, meaning how much air we have available to us. And I think the three main ways to think about the way that the brain and body communicate is that it's either going to be mechanical or chemical. Let's use the gut as an example. Your stomach can feel acidic, or it can feel nice and warm and fuzzy, whatever that is in a chemical sense. Your heart rate can feel like it's going at a rate that's appropriate for your circumstances. If you're running, it could be quick. And if you're sitting in a chair quietly at the doctor's office waiting to be called back there, and all of a sudden your heart starts racing, then you would think, well, that's appropriate for that situation, but it's uncomfortable, right? It's out of sync with what you are doing, which is sitting. So there's mechanical information, and then there's chemical information. And with respect to your lungs, you can feel like you're out of air or you have plenty of air. You can feel like your breathing is labored or it's easy, or in the chemical sense that the air that you're breathing, your lungs are burning, or it feels easy to breathe. So basically there's chemical and mechanical signaling from the body to the brain, and the brain interprets all of that. And we put all of that under the umbrella of the so-called autonomic nervous system. And the autonomic nervous system can really be best thought of along a continuum. And here I'll avoid complicated nomenclature, but I'll throw it out there for the aficionados. Some people have probably heard of the parasympathetic and the sympathetic. That naming is a little bit misleading. Again, what we can really think about the autonomic nervous system as is a continuum, or more like a seesaw, of at one end is alertness, and at the other end is calmness. Right? That is translated to the so-called sympathetic and parasympathetic nervous system, but I'll call it the alertness and calmness system just for sake of simplicity. So it's sort of like a seesaw, and it has different neural circuits, and basically whether or not you feel very alert or panicked, or alert but calm, or a little bit of anxiety, that's going to depend on the balance between this alertness system and the calmness system. If you're having a full-blown panic attack, then the alertness system is, it's as if the seesaw is tilted all that way. If you have If you're deeply asleep, well, then the calmness system is really tilted down. You could say that's a portion of the seesaw. This is all kind of obvious and dates back, 100 years or so, which isn't that long in the history of science, but we've known this sort of thing for a while. Okay, what's interesting and I think more relevant nowadays is to think about one's own interpretation of those signals and how that relates to anxiety and, as you pointed out, exploration, and then to think about where the nodes of control are. In this seesaw model that I'm putting forward, the seesaw has to include what I would call a hinge, a location in the middle in which you can voluntarily adjust the seesaw to either be more tilted toward alert or more tilted toward asleep.